So hello everybody. So this is the title of my talk, Web Development Should Be Easy. I will try to explain what that means and more or less why we started building web2py. And first of all, I want to thank the organizers and this wonderful conference, and the food here is excellent. And also I want to congratulate Mariano, who's a new member of the Python Software Foundation. Okay, so let me first ask a question that some people ask: should everybody learn to program? Now, first of all, what do I mean by this? Should my mom learn to program? That's not exactly what I mean. What I mean by this question is not, and also I don't mean should everybody actually be a programmer. The question is, should people know what a program is, how you build programs? And so the question is, should people learn how to do it? Is there a value in that? More specifically, we can ask, should every child learn to program? And to this question, I definitely would answer yes. I think the new generation should learn how to program. So let's see my reasons for that. Well, the color doesn't render very well. First of all, there are studies that show that if you know how to program, you improve your cognitive skills. Well, people have shown that it's not sufficient to learn the syntax. It's important to apply programming to solving problems. But you learn many things if you do that. You improve your cognitive skills. Also, there are reasons related to job opportunities, because people project that in the next 10 years, there will be twice as many jobs created in software development than in other areas. So the jobs in software development will grow twice as fast as in other areas. But also, I think we want our kids and the future generation to understand technology, not just be consumers of technology, which is, I think it's a big problem today. We all use a lot of technology, but most people don't understand how it works, and that creates problems. So understanding science and technology is essential for the progress of society. And in particular, computing technologies is what has given us unprecedented means to communicate and build different types of social relationships that people were not building before. Now we are able to meet people who are far away, and we can do that thanks to technology. And I think programming plays an important role. People who are programmers interact with people who are far away more than people who are not programmers. People who are not programmers tend to only interact with local people. And also, it's important, so this technology can be used for good, but it's also used sometimes in ways that we don't like to take away our rights. Like we buy a digital book, and it's not clear who owns it. So when I die, can I pass it to my child? I don't know. And stuff that we put on the cloud, who owns that? So I think there's also another value in having people learning to program and building an economy based on building software as opposed to building physical things. So we have this capitalistic model, which I'm nothing against it. I mean, it works to some extent, and makes a distinction between people who invest, for example, in a company by paying for the means of production, and the workers who actually build the product, and they both have profit. Well, software is a little different than that, because the means of production is your education and is your laptop. So you are kind of an investor of yourself. You can start your own company without necessarily having somebody investing on you. And that's kind of a different model, and it allows more, for a less hierarchical society. It allows people to dream about having a better position in society. That's, to me, a very important reason to get into software development. And also, the kind of product we make, which is software, has economic value, has social value, but also it's something that we can easily replicate at no cost, and we can discard without polluting the environment. So it's an important part of the economy. It's an important part of the economy which is growing, and there's lots of benefits. So the production of digital content, specifically software, is something that will continue to be important, and I think we should welcome that. We should have more of that. We should value software and have more in our society, more digital content. So what kind of society do we want? Why is this important again? Like today, we start seeing on the market machines like 3D printers. We can buy a 3D printer for like $2,000 for a small one. And we already see that people are starting to oppose that. It's not okay that you build things at home because that undermines our current economic model in which there are companies that are supposed to make things and they own the rights and so on. So we had to make a decision which kind of society we want. We want a society in which we restrict what people can do in terms of building intellectual content, software, digital content, or we want a society in which things are shared and it's much easier to make things yourself, even physical objects. And physical objects will be made from digital content, which is something relatively new that is going to change our society even more. So I don't know how we go about that. The only thing I know is I think we need to teach more people how to program. So my next question is, do we teach programming well to our children? Do we teach it in school? Well, I'm a professor, I teach in a university, and I see a lot of that, okay? Students come in, he has never programmed before, and is confronted with public class hello world, public static void main string args, sys out print line hello world, okay? So we're trying to teach them that we can tell the computer to print something. And we have a lot of additional structure there that scares people away. And so we put a lot of obstacles in the way of new programmers. And the obstacles are of various nature. The first obstacle is they have to use some kind of shell to type commands. Well, they don't have the concept yet that you give commands to the computer. So the moment you present a shell, they get a little confused. Also, there are lots of shells. There is the Linux bash shell. There is the Windows shell. There is the Python shell. And I see students who are master students who cannot tell one from the other. They type Python commands in the bash shell. They type bash commands into the Python shell, and 50% of the students come to a university in America and they don't know that Windows is a shell. They don't know where to type the commands that I give them. So that's a problem. Another thing is IDEs. Now, IDEs are useful if you are a good programmer. They have a lot of features like auto-completion, but they also have a lot of buttons that scare people away. Myself, when I try to use the Microsoft IDE, sometimes get confused. I don't know what the different buttons do. We also focus often on languages that teach syntax and not semantics, so we have to understand what the semicolon mean and things like that. And most importantly, I think we use examples that do not leverage on what's the student knowledge. So students today, at every level, even at the elementary level, they go to school and they already know how to interact with computers. They know how to use YouTube, they know how to use Facebook. My kid is 7, he's addicted to YouTube, right? So we don't leverage that. We go there and we say, okay, now type the Fibonacci sequence, code the Fibonacci sequence, code complex numbers. They don't know what that is. They don't care. Some do. People will become engineers. They are interested in that, but not everybody. Also, we don't provide motivation. Those examples that people use in intro classes are not interesting to the majority of people. It takes a long time in a computer science degree before the students get productive and can build something which they consider to be useful. And we have a lot of classes which are for non-computer science majors in which we never teach them to do something useful. And that's a big mistake, I think. We also have this bottom-up approach as opposed to a top-down approach. So we start from the very basic concepts which historically are the foundations of programming, which are the for loop, the if statement, and then we go into function calls. And eventually, after years, we get into building a web application. And I think we should reverse that. I think they don't know why you need a for loop. People don't know what they need the if statement. So first, we should start to teach them how to build complex things using complex blocks. And then we should take a more scientific approach and explain them how do these blocks work. These blocks are made of smaller parts, which are made of smaller parts, and eventually, the if statement and the for loop and the function call are the smallest parts. So one thing we can do better, and I think here everybody agrees, is, we can just get rid of all the fluff around there and leave only print hello world so we can use Python for intro classes. So where I teach, we started to do that with a lot of success. Our intro classes in computer science now use Python as an intro course, and then they take advanced programming courses. But you know what I find very strange is that we were able to do this for computer scientists, but not for all the other majors. For the other majors are still using Java. And I think we need to do a better job at convincing people that Python is a better language for the introductory computer science. Well, can we do even better than this? Well, I think we need to provide motivation. So from the beginning, we should teach students how to build not simply print hello world, but to build web applications. So print hello world, post it on the web for other people to see. I think that's the big change that we should do, and I don't see this done anywhere. People still program these very simple examples that don't give a motivation. So students are already familiar with the web, and we will give a lot of motivation by teaching them how to program web applications. And again, who here as a kid was not addicted to YouTube, right? Okay, so this is my job. This is why I'm giving this talk, and this is why I build the things I build. I want to make web development easier, more accessible to people. And my main audience is not necessarily Python programmers, but bring people from outside and less error prone. Building web applications it's complicated today. There are security issues. It's complicated to teach those security issues. You can make errors that cause security vulnerability. So my interest is how can we make web development easier, more accessible, at the same time enable people to build programs with a lower chance that they make a security mistake, and more modular. Now, I don't claim that I have any success in this. I mean, I will show you what I've been working on, but I don't claim any success. I'm just saying that I'm trying to do this. This is my goal. My goal is not to make the fastest web application. My goal is not to make the most Pythonic web application. My goal is to make the easiest one to use. So 2007, I was teaching courses on web development. I was using other frameworks, and I had all these problems. The students, I could not get them up to speed after 4 weeks. They still were confused about basic things. So I started making web2py. And what's web2py? Web2py is one file, which is a zip file. You can get a binary version, source version, and so on, or for Mac or Windows. And includes basically these three things. It includes the web server, the database SQLite, and the database abstraction layer. So it works on top of SQLite, but you can replace it. It does migrations in the sense that you never talk directly to the SQL engine, not even to alter tables. It does that for you. And includes a web-based IDE. So when you unzip web2py, you just unzip it, click on it, it starts. It even opens a browser for you. You don't have to open the browser. It does that for you. And you get the whole IDE in the browser, and it's a very simple IDE to use for new students. And there are no configuration files. It's not that you don't need to do the configuration, just there is no configuration file. It's supposed to work anywhere Python runs. And we package it with it all kinds of libraries that we think are important for web development, like libraries to generate HTML, XML, JSON, RSS, ICS, PDF, RTF, handle various protocols like XML-RPC, JSON-RPC, SOAP, different authentication methods like LDAP, PAM, Generate, Dropbox, Google, CAS, OpenID, Auth 1 and 2, X59 certificate. It's all built in, so you don't have to worry about going fish for the right library, third-party library, which may or may not work with your version. Libraries for generating wikis like MarkMin and Markdown, and libraries to talk to Google Wallet, Authorize.net, Stripe.com, payment systems, Memcache, Redis, Twitter, and it's based on Twitter Bootstrap, but you can change that. Also, one more requirement of web2py, we made it in 2007, and we required always to be backward compatible. So we never broke backward compatibility since 2007, except for one security issue. So if there is a security issue, we would break backward compatibility. It only happened once, like 3 years ago. Now, web2py has a lot of contributors. I've listed some here. One of the main contributors is Mariano Reingart, which is one of the organizers of this conference. So thank you to all the contributors. We've been doing relatively well. We got two kind of important awards. 2011, we got the BOSSI Award, and in 2012, we got the Technology of the Year Award from the same source, both of them. So this is how it looks like. You unzip web2py, you start it, and you get this IDE. And this IDE, basically, on the left-hand side, it lists the applications that you have. And you can have many applications at the same time under the same web2py instance, and you can do various things with these applications. On the right-hand side, you can add more applications, you can create a new one, you can update web2py, and you can install application locally or remotely. And what it shows you there with the iPhone, it shows you that this Web IDE is also available for mobile devices. Then you click on one application, and what you get the internal structure. So it's a MVC framework. So the internal structure consists of models, controllers, and views mostly. There are other folders. Now, the two things important here to stress. First is the Web IDE is useful for new users. It's convenient if you are doing some work remotely, but you don't have to use it. It's not a central part of web2py. Web2py is a bunch of libraries like Flask or Django. You can do everything from the shell. You can edit all your files from the shell. But the IDE itself is an application that runs on top of those libraries, which you can even uninstall completely, and everything works. The second thing is the folder structure that you see, everything that the web interface shows you corresponds to just files and folder in the file system. So here we see we are into the application welcome. This means that there is a folder called welcome. And inside there are models, controllers, views, and so on. And those are just subfolders. And inside there are files. And those are the files in the system. There are no other files other than those that you see in the web interface. You can edit a file on the web interface. You can edit using Emacs from the shell. It's the same thing. There's no metadata anywhere. The only thing that the web interface does for you is first, it groups them in a way that kind of makes sense in a logical sense. It allows you to edit those files. It also parses those files and finds what's in there. Like it finds that in the controllers there may be some actions defined. So it shows you links, so you can just click on the link and run it. Same thing with the models. It shows you which models you have defined and which tables you have and things like that. So now you click on a controller and you get just a web-based editor, something like this, where you just type in there def index return hello world. It finds that there is a function index that returns hello world, and on top there, where it says expose, it's going to list that there is a function index. You click on it, it's going to run it, you're going to get the web page you're looking at. We have a web-based debugger, which was created by Mariano, which I think I broke in the latest release. And I'm fully responsible for that, so we'll fix it soon. Also, every application that you run under web2py has its own database administrative interface, which is kind of the poor man's version of the Django admin. It serves the same purpose, but there's a major difference. The Django admin is designed to be exposed to the users and customized. The web2py admin is per application and is designed for the administrator. But the controls that are in the admin can then be embedded into your own applications, and I'll show you that. We even have more sophisticated controls than those used in there. So when you make a new application in web2py, it already comes with some tables, which you can delete if you don't need. So you have authentication table for role-based access control. So you have a user, group, membership, permission, and event. Event are login event, logout event, and failed access events. We have a table called AuthCAS. Every application in web2py is a central authentication service client and provider. So you can install two applications, and you can ask one that the other one will do authentication for it, so you can delegate it. We also have scheduler tables because it comes with a built-in master workers scheduler. So you can start many workers, and you can schedule a new task by entering a new record in one of those tables programmatically or using the interface, and it will run the tasks in background, and the workers available will pick up the tasks. We also have an internationalization page. So anywhere in the code you have a string, you want that translated in a different language, you just put a T in front of the string, and then you click on the button that corresponds to your language, and you get a page in which you just translate those strings in the other language. It's yellow if it's not translated already. It's white if it was translated already. And then you just translate through this interface. Also, we have a pluralization system. So web2py understands the rules of many languages. For example, understands the Slovenian as 4 types of plural, depending if it's 0 objects, 1 object, 2 objects, or more than 2 objects. Okay, it understands that. And depending on the language you are translating, you can specify which words needs to be pluralized. So you may have a print statement, you have X emails. X can be 0, X can be 1, X can be 2, X can be more than 2, okay? So what you want to do is you want to say X is a variable, email needs to be pluralized based on the value of that variable, and this is how you pluralize it. You go to the web interface, you type the word email, you type the plural, you type as many plurals as you need in the language that you're translating. We have a built-in ticketing system. And again, this is really useful for many purposes. Think about, so most web frameworks have a distinction between development mode and production mode. Where you enter development, if there is a bug in your application, you get some kind of trace back. Okay, you see what was wrong in your application, you can explore the variables, you can go through the stack trace. When you enter production mode, that information may be lost. Some frameworks allow you to connect to a tracking system where eventually gets recorded. This is built into web2py, and we don't make a distinction between production mode and development mode. If there is any bug in the application and any user encounters this bug, web2py takes the entire stack trace, stores it into a ticket, and gives the user a ticket number. If the user is an administrator, the user can click on the ticket number and can see the stack trace. If the user is not an administrator, can email the administrator and say, I have this problem, this is my code, this is my ticket number, and the administrator can go through. The web interface also looks at all the tickets that have the same error, groups them together, so you can see which error is happens more often. And you can just look at one of them as opposed to look at a lot of errors that basically may have different variables, but they are exactly the same problem. Another thing we have with some high-level controls, for example, one is the grid. So let's say you have a table and you say, I want a grid based on this table, and the grid is a widget that allows you to add a new record, list records, do pagination, search records, add new records, update or delete, and it's customizable. So you can say, I want the record to be represented in this way, I want this field to be represented in this way, I want to disable the feature of adding, I want to set permissions so that only these people can edit this record. So there are all kinds of things like that you can customize. So now let me step back, and again, let's talk about the syntax of web2py. Now I just talked about the web IDE. So let's talk about the syntax a little bit. So let's remember this distinction between the Java syntax and the Python syntax. And let's keep new programmers in mind, not experienced Python programmers. So this is how you do hello world in Bottle. Bottle is my favorite micro framework after web2py. And so this is how it works. From Bottle, you import everything you need, and then you write def index return hello world. That makes that just defines a function, and then you say you want to turn that into a web page. So you say @get/index. So that means if you do a get request for the page /index, that function should be called. Then your application may need to handle static files, may need to serve images. So you need to tell Bottle that you want to handle static files. So they would be under /static/filename, and you need an action that can do that. And at the end, you start the web server. Okay? All we want to do is write a hello world. Same thing with Flask. So in Flask, from Flask import Flask, and app equal Flask __ name. Now explain that to a kid who's just learning to program. That's my issue here. They all have other things in common, like app root /index. So you are mapping a URL into a function. Same thing with Tornado. Tornado, you are grouping the roots in one place, and you need a class instead of a function to handle the requests, and then your class can call the function. This is the pyramid example. It's even more complicated, but it's all the same idea. So we made web2py because we wanted to be able to do that. We want to be able to say, you just type the name of an app / the name of a file /index. It should call the function index in that file. That's what we wanted to do, and that was the basic idea from which the whole thing started. And we wanted to do that through the IDE. And then it should give me a page which says hello world. So as simple as that. Now, people are very confused by that. They say, where is everything else? And yeah, that's a good question. So this is how things work inside, and this is the main difference between web2py and every other Python framework. Every other Python framework, you start from the user application, and you import the libraries of the framework. And then you start the web server. They all work like that. In web2py, we do the opposite. You start the framework even if you don't have an application. And that executes the user application. And because it executes the user application, actually you can have more than one, and each of them has its own environment. So if you look at the right, this is more or less the logic in a way which is more very simplified. It's not exactly that. But, so a request arrives. First of all, the request is parsed. So we validate the URL, we validate other headers, we establish a session, we determine which language is being requested, we look for the proper translation file. We do all kinds of things that the user may or may not need, but we still want to expose them to the user. Then we build an environment based on this request. So we know what the client is telling the server, and we build this environment, which is a bunch of symbols, a bunch of variables. Then we find the application which is being requested from the path info, and that's basically a folder which contains a controller file. And then we execute the controller file into that environment. Okay, so that file already sees certain variables. The variables it sees are very well documented. It's always the same. It's not that many. And there's not much change there. If you read the documentation, that's pretty straightforward. So there are two different approaches here. In the left-hand side, so most frameworks prefer to follow the Python motto, which explicit is better than implicit. And that's perfectly fine. For me, I prefer to follow don't repeat yourself, because I want to make sure that it's as easy as possible for new users. And also, we follow convention over configuration. And so in some sense, we are closer to Rails than we are to Django. Everything is a default. Like if I make my action index, and I call index.html, I get a default HTML representation. If I call .xml, I got an XML representation. If I call .json, I get a JSON representation of the data without doing any coding. Now, I may not like what I get, so I can change it, but I have a default. Like, I can create an action, and I don't need to define routes like you do in urls.py, like you do in Django. You don't need to create views. You get the default one. And then you go and change it if you don't like it. You should change it. Different approaches have different pros and cons. So the import approach is faster, specifically for simple apps. Sometimes it's faster for a more complex app, mostly because there's some code which is executed only once when you import it, and then it's not executed anymore. It gives you a little bit more flexibility, and in some sense there is no magic there. In our approach, we have less code, so I believe it's faster to develop with our approach. It certainly is slower for simple applications, because there are certain things we do even if you don't want. So it kills us in a low-word type of benchmark. Like, we create a session even if it's not used. We determine which language is the proper translation even if you don't use it. Okay? So that kills you in certain benchmarks. It does not affect you very much in real-world applications, so we don't mind. We're working anyway on making some things lazy, so eventually we'll improve on that. We can do hot swap of code. So it doesn't matter which web server you're using. You can use a production web server like Apache or Nginx. You can, while the server is running, you can replace any file, you can install a new application, you can delete an application, and nothing gets affected. You can have multiple applications at the same time. What I call an application is what Django calls a project. So if you have Django, you have one Django installation. Typically, you have all your files share one settings, and that contains the connection database. In our case, we can have multiple applications under the same instance of the framework. Each of them can have one or more database connections or zero, and they can share database connection, but by default, they're all separate. And they have completely different, they don't have any configuration file, but they're completely isolated one from the other. They can even come with their own Python modules separately. They all see more or less the same environment. Well, there is some magic involved, so eventually you need to read documentation to understand some of the things. Another thing which makes, and again, here I'm making web2py examples, but some of these concepts are more general. Another thing that scares new users, in particular when they go to build web applications, is that you have layers of code. You like embed SQL into Python. Okay, you have something like execute, and then you have select. So you have an SQL statement into a Python code or any other language. Now, that's conceptually complicated to understand. Is the cause of many problems like SQL injections. So what's the solutions? Well, some frameworks have an ORM. Some frameworks like web2py, we have a database abstraction layer, and I will show you some examples of that. Another thing is sometimes you have HTML inside code. You have a piece of Python code needs to generate HTML, and you end up doing string concatenations. Again, that's a source of errors. It's logically complicated. So you still need to understand it to some extent, but in web2py we provide helpers, and the helpers in web2py have the same names as the HTML tags. So div is called div, h1 is called h1. And so you never do string concatenations. You just use the helpers. Sometimes you need code into HTML, so that's what you do in the templates. And well, the MVC model helps you a little bit because you minimize the logic that you put into the HTML, but you still need to do it. Well, we don't have a solution for that problem, but what we can do is we say that we use pure Python into the HTML. You just forget indentation. A block starts with colon and ends with pass, which is a Python keyword. And it gets reindented internally automatically, so you don't need to worry about that. But you don't need to learn another language. It's exactly the same. Anything you would write in Python, you can put into a template. Another thing is JSON into HTML. That, again, scares people because it's one language instead of another language. Well, again, sometimes you cannot really avoid that, but we have something called the load function, which allows you to load one action into a template via Ajax. And let's say that action contains a form, which is self-submitted and so on. The whole thing is automatically done for you via Ajax, and I'm going to show you an example of that. This really makes certain kind of JavaScript functionality easier. So let me talk again about the web2py database abstraction layer, which for most people is kind of the nicest thing in web2py. And in fact, if I were to rewrite web2py, I would rewrite a lot of stuff today, different than the way I did it years ago, but I would keep this. So here's, first of all, we support really a lot of databases out of the box. We actually support more, but some are not really well tested. Those ones are tested. We have automatic migration, so you can add a field, you can delete a field, it talks to the database, does alter table. We can support multiple database connections for every application. Connection pooling, round-robin redundancy. So if you have a master-slave database with many database slaves, and you may want to try to connect to one of them at random, and if it fails, you want to try to connect to the next one, you would do that. It has distributed transactions cross-database. You may have a connection to PostgreSQL, one to Oracle, and you want to do a distributed transaction. It does that. It supports joins, left joins, aggregates, nested selects, recursive selects, and you can merge them. The idea is it's not an ORM. We're not trying to map SQL into Python. I don't think that can be done reliably. It can be done, but you have limitations if you do that. So what we try to do is we try to have a Python syntax that corresponds exactly to the SQL. We just make it in a dialect-independent way. So you write it once, and then you can swap the database engine, and we'll rewrite it for you. So here's an example. DB equals dal SQLite. So it makes a connection to SQLite, and you can replace that with Oracle, Postgres, or whatever. And then you say define a table person with a field name, define a table thing with a field name and a field owner, which is a person, and DB thing insert, name Mac. So there's a new thing, which is a Mac, which is owned by DB person insert Max. So Max owns a Mac. And now you say, there is something that says ownership equal. So I'm creating a relation. Ownership equal is a relation between a person ID and a thing owner. So a thing owner is a person ID. And then I say, nthings is a variable that says db thing ID count. So count the IDs of things. At this point, I'm not talking to the database yet. There is no database interaction. And then I say rows equal db ownership. So from this ownership relation, that defines a set of records. Select the person name and the number of things, ordered by the person ID, grouped by the person ID. So that's doing a join for me, and it's doing an aggregate. And then for row in rows, print the row person name and the row number of things. And I get a list of persons and how many things they own. And that's how we write almost every query. And what you see is that insert maps into SQL insert, select maps into SQL select. We also have delete and update, similar syntax. There is no other keyword. Everything else is done with operator overloading. Well, there is another thing we are working on right now, which I can try show you. So I'm going to do this more interactively. So I'm going to sit. I'll type better if I sit. OK, so this is the administrative interface. I log in. This is what people see. You have an application, my app, which I made. I'm going to uninstall it. Yes, I'm sure. Now I want to make another one, and I call it my app again. So I just made a new app. I can see the things in there. I can make, for example, a new table. And I go here and code it. And I made it. So I go back to the edit page, database administration. I have a table. I can already insert stuff in it. I can look at them. And I'm going to go back to the design page. I get a log. I can see the table was created for me. I can go and alter it. So I can go and I can edit this table, and I can say I want to add another field, which is description. And this thing is text. And then I save it, go back to edit, database administration. If I click the new record, I see that this is here. And actually, let me do one more thing here. That means I have another field which is created on, which is date time. And again, same thing, edit. If I look at this, I already get the pop-up. And we have pop-ups for various types of fields, date time, time pickers, things like that. And again, if I look at the SQL log, it did the alter table for me. I did 2 alter tables. I added the description, and I added the timestamp. So I really, very rarely you need to talk to the database ever. Well, what can we do programmatically? Let me delete a few things that are in here. Let me put the def index return hello world. So I'm going to save it. And I can click it. I say hello world. Let me return a dictionary, which have like rows, which is database db thing select as list. So again, we can look at this, and I get the rows. I may want them in XML. Let me do JSON first. OK, so JSON works. XML is missing the top line. That's a bug in my version. In principle, you can do things like .rss. It's just that there's no RSS type of data in there, so it's not give me RSS. But if there were events with start time and end time, it would make the RSS. You can do ICS, you can do Google Maps the same way. Let me make 2 more things. Let me make a form for the big thing. Let me return a form. Select. Process. OK, so if I do this, I get an entry form. So it's a widget I can add everywhere. Let me make a more complicated form. Let me make a grid thing. And let me require login. So, OK, now it says you have to log in. So I register. So all this stuff is out of the box for every application. OK, so this is the widget I just embedded, so I can create a new record. And OK, I can view it, I can edit it, and so on. I can delete it, I can search them. I can build queries, name contains C, and things like that. I can export them in different formats, and I can customize this. With, I can register callbacks, I can do various things with this. Okay, this is still this one final thing I want to show you, which is, go back here. I'm going to rename this thing. I'm going to call it manage, and I'm going to return just the widget. So if I call manage, this should do something, right? If I call manage, I just get the HTML. I don't get the frame. Now I'm going to return something called auth-wiki. And so this is a new feature that we have. So if I now call an index, this is exposing our whole wiki. So I can create a new page index from no template, from this slug. So the page is my own page. And here I can embed things like I can tag it with PyCon Argentina, and so on. I can edit this page. So there's a wiki syntax to do things like like lists. Let's do one thing. Let me go to YouTube. Let me search for some video. It doesn't work. Yeah, it does work. Okay, so here's a video. So I can just cut and paste the link here, and I can do a preview, but I'm just going to submit. So it talks to, use the OEmbed protocol, talks to YouTube, embeds the video, it understands what kind of embed server protocols. But now what I can do is I can use the wiki, I can create many pages through the wiki, I can edit the menu, like let me make a menu here, and then things like this. So here I just added the menu. So I can build my whole application as a wiki. And in particular, if I go to my manage pages, my own page, edit the home page, I can also embed components. So the thing I built, which is default manage, the managed things. So my form is now embedded into my application. And when I submit a new thing, like a table, this is submitted via Ajax. It's not refreshing the whole page, it's only refreshing the component. 2 minutes, okay. Well, this is what we just built. This is the total code that we just wrote. And there's a lot of things. So this shows you the same thing I just showed you. So what is my conclusions? Well, my conclusions is that there's some elitist approach to programming. Only people who can do should do it. The other people should not even try. I think that leads us to the wrong path. I think there is not one solution. Different people are trying to teach programming in different ways. And also there is not one web framework. Different web frameworks have different strengths and weaknesses and target different kind of audiences. And what we need to do is, I think we need to learn from each other. I think we learned a lot from other frameworks. I really owe a lot to Django in particular. It's the one I was using a lot before. I think I learned, almost everything I learned is from Django. We took some ideas from Flask. Like from Flask, we took the idea of the thread local context, which I did not show, but we use it internally. I think we need to build a better society where technology is controlled by people and not by large corporations. And the way to do it is to get more people to program. And that's why I'm doing this. And we need to build tools that are easier to use for users and more effective, that allow people to use the web in a more meaningful way, in which if they have data, they can expose the data, they can expose your opinion, they can automate processes, and this really empowers people. I think it's really important we do it. I'm done.
Ahora tenemos las preguntas. Si alguno le ayuda, por ahí puedo traducir, si no, como quieran.
Sí. ¿Por qué, en tu opinión, no hay tantos ISP que puedan ofrecer el servicio de soportar web2py, siendo que es tan bueno realmente, porque soluciona muchos problemas y uno puede desarrollar de una manera muy ágil? Pero no hay tantos ISP que lo soporten.
Do you need translation?
I need translation. Sorry.
Why there's not so many ISP that that supports web2py as default? Because he said that it's such a good framework, but most ISP doesn't, or hosting doesn't support it.
Good question. Well, normal hosting services that have a regular virtual machine with a file system, if they support Django, they support web2py because it's WSGI application. They may not say, but it's exactly the same thing. So if they support any other Python framework, web2py works. The exception is some places like Heroku, for example, which they don't have a writable file system. Web2py uses the file system and needs to write it. Like when you upload an application, you are writing in the file system. So that's the main problem we have. I mean, we could deploy on Heroku if we were to package an application and give the application to them, as any other framework does it. But our distinction is that people can go through the web interface and can change the code. And they don't allow that. So we don't have a solution for that. I mean, we could, one solution could be, we could store the applications themselves in the database. I don't think it's a good idea because of performance. I mean, we could cache it. We would have to create a lot of new structure for that. So any virtual private server, any shared web hosting that is a writable file system, if Django works, web2py works. And the instructions are exactly the same. Instead of calling the Django handler, you call the web2py WSGI handler. Same thing. Heroku and a few other things like that, we're working on it. OpenShift, we work on OpenShift. In fact, there's one thing I didn't show, which is if I go to the administrative interface, here there is, you can deploy on the Google App Engine from the interface, and you can deploy on OpenShift directly from here. So it takes your applications and puts them to OpenShift. You need to configure it. This is one thing you need to configure it a little bit. Like in the case of Google App Engine, you have to tell it where it's your app CFG configuration file, which applications you want to deploy. I want to deploy this one, I want to deploy this one, and then your Google password, and then we'll deploy on Google.
¿Preguntas? Bueno, gracias.